Hi friends, today we are going to see about a max beginned SVM algorithm. We already see about SVM and what all are the concept is behind the SVM. I already upload the video on YouTube. These are the basic concept that are begin the SVM algorithm. We need to find a hyperplane which can separate the data points in a n-dimensional vector space. Today we are going to see about the max begin the SVM algorithm. Okay, in an SVM algorithm we simply take a two-dimensional vector space. The first dimension is x1 and second dimension is x2. Let's consider some of the data points are here, and some of the data points are here. Our task is to find a hyperplane that separate these two groups. This is the hyperplane, and there is another supporting line that was called as marginal line. This marginal line is parallel to the hyperplane that touches each of the point in a group. That points are more like to have a less distance from the hyperplane. The marginal line should touches each of the point which are nearest to the hyperplane from each group. For an hyperplane, whenever we in mathematics we have a formula called a linear formula. It's called mx plus b, y equal to mx plus b. This means that this is a line of an equation like that. For the line of hyperplane, and for these two lines we have an formula, this linear formula. For this hyperplane we can consider this hyperplane as a formula of mx plus b equal to 0. Let's consider this hyperplane having a slope of -1, and consider this hyperplane touches the y axis, x2 axis when x1 is 0. But here I have draw this line little bit away from the origin. Just you consider this line is present inside origin, so that the intercept of this line is 0. This represent the intercept and the slope represented by m. For this line consider intercept is 0. Okay. In an SVM algorithm, we have a formula to calculate the plane y equal to weight w of w transform x plus b. Here we consider b is 0, so we get w transform x. For example, let's consider this point is lies in x-axis and the point is in x comma 0, and consider this point is present, this point is x comma 4. Just consider. Okay, whenever we apply this formula to this point, we will get, let's first we write w of t. W of t means the weight transform. Here the weight is -1 and b, -1 and b intercept equal to 0, and we need to write x value. We need to apply this formula to this point. Here we indicate the point as 4, 0. After we do matrix multiplication to these points, we can get 4 as 4. So like this, we need to apply this formula to all of this point. After applying this formula to all of this point, we will get answer in a positive format, in positive form. Whenever you applying this formula is represented this formula is represented the hyperplane. Whenever we applying this point in this hyperplane formula, we will get a positive value for these all point. Then we have to apply this formula to all of this point that are presented in this side. Whenever we are applying this formula to this, whenever we are applying the point into this formula, into this formula of hyperplane, we will get w of t x plus b equal to w of t plus x equal to 1 minus 1 0 plus 4 comma 4 2. After we doing matrix multiplication, we will get answer as -4. Whenever we apply all the point into this formula, we will get minus value for the value which are present in this area. We will get positive and a negative value. So that whenever a new data is come, we need to apply that point into this formula. Whenever that point will get a positive value, that point will be considered to be belongs to this group. Whenever the points are giving an output of negative, we can consider that points are refer to this group. And whenever we getting a positive value, we just consider that positive value as plus 1, and whenever getting a output as negative, we will consider that point as minus 1. We all know that it just consider this SVM. This SVM is 3 lines. Whenever we remove these 2 lines, we will have a hyperplane. This without these 2 lines, this structure, this algorithm, it acts like a logistic regression, because in a logistic regression there will be having a line that will separate the 2 groups linearly in a n-dimensional vector space. Like this only SVM also separate, but in addition to this SVM having a another marginal lines. This overall distance between 2 lines is called margin. And our main aim is to find a hyperplane which having a high value of margin. But how this will happen? Let's see for more deep. Okay. For an positive value, we will get transfer of t x1 plus b equal to minus 1, and for another group we will get like this. In this example, this value is represented using this formula. The line which touches the positive, the margin line which will touches the positive point will have a formula of mx plus b equal to 1, and the points which are the line which touches the negative point, a point which having a negative output, that line will represented in this format by this formula. After substituting these 2 lines, we will get answer as w of t into x1 minus x2 equal to 2. To remove this transform, we need to apply norm. Whenever we apply this norm, it will when applying this now, it will regularize the model. What is regularization? Whenever we have a model that should be perform well, in any scenario. To train a model like that, we will apply some regularization technique. In SVM, whenever we get a let's let's write let's write this condition. Whenever we getting negative point, negative value of a point, we will consider -1, and whenever we getting output of +1 for a point, we will be considered as +1. We can write this condition in this form. That means y is equal to +1 whenever the output is greater than 1, and y equal to -1 whenever the output is less than or equal to -1, and we have to consider another thing. Whenever we train this model, we need to update the weight and bias. This weight and bias should be smoothly updated. To do this, we have to apply the regularization technique. This is the regularization formula technique. This is the regularization technique. By applying this formula, we can regularize the model. This C is responsible for regularize the model, and this C represented how many errors are across whenever we training the model, and this will be, and this epsilon of 0 to n will represent the value of an error. By applying this condition, we will regularize the model, and these formulas will smoothly update the weight and bias of an SVM. By applying these formulas, we can get a good SVM model. This is the main concept behind the SVM algorithm. Like this, the SVM will apply the technique to each of the point and find whether this point is referred to positive group or a negative group. We all see a basic example of an SVM, but in real time scenario we cannot see two-dimensional spaces. In a real time scenario, we have many dimensional space. For those space, the SVM will apply polynomial SVM, polynomial linear formula to find the best hyperplane. Okay, this is the major mathematical concept which are begin the SVM. We can see another algorithm tomorrow. Thank you.